Hello, everybody. My name is Chris Murphy. I'm a senior technical artist with Epic Games on the tech consulting team. And today we're going to be talking about stylization in Unreal Engine. Don't stress, we'll get this and we'll go several steps beyond what you're looking at. I'm going to forward this with something because I feel a little bit, I don't want any programmers throwing things at me from the audience. So I'm going to start off with this. It's like a caveat. Today we're going to be going through the kind of things you can do to stylize your project using materials and post-processes and that kind of stuff. I'm not going to be touching on writing your own shader model or anything of the sort. So if you do have access to a rendering engineer who wants to do it their way, I totally get it, and that is a good path to go down. But if you are working on a project that you want to kind of test different types of looks out and try different types of things without necessarily going down the pathway of writing your own entire shading model, I get it, and that's what we're going to be covering today. But within this project, which some of you may recognize as dating back as ye old 2014 assets for UE4, I've got this project because I kind of want to take it a little step further and do a little bit more. What I want to fix first, though, is see this grass? It's kind of gnarly. So what I'd really love to do is begin with kind of fixing that grass into some sort of stylized way that really kind of helps it match the aesthetic for the rest of it. Now, few things that I want to do here is I want to get that grass and I want to make it match the landscape that's beneath it, which is a somewhat stylized landscape. If I come up here, you can kind of see there's a little bit of patchwork going on there. I really wanted to match that color, and I also wanted to kind of match the normal of it. That will make more sense in a second, but the TLDR is this. Think of any anime grass you've ever seen, and that's what we're going to be going for. Which means, first things first is I'm going to go ahead and I'm just going to nuke the shadows on them, because by default, we don't really want to have that in there. We can get rid of that, and we can now see that already that's looking a little bit more stylized, but now we just have this flat block green, and that's really not what I'm after. What I'm after instead is matching the color from one asset to the other. Now, there's a really cool feature in Unreal called Runtime Virtual Textures, which is really a fancy engineer's way of saying we take a screenshot of the ground at any given time, and everything else can kind of look up what the ground looks like. And we're doing it in a memory conservative way. I'm sure somewhere out there is a marketing person who didn't want me to describe it that way, but that's essentially what we're doing. So I'm going to open up the landscape material, and I'm basically going to say, hey, when something screenshots you, this is what I want you to look at. And to do that, I'm going to create an output for a runtime virtual texture. I'm going to say to it, hey, if something asks you what your base color is, tell it that. If something asks you your spec, roughness, and for normal, instead of reading in the normal map, I'm actually going to give it the world space normal. So I'm going to tell the ground, if something asks you which way you're facing, I want you to just tell it that you're facing your pixel normal direction. Okay? So we get that out of the way. I'm going to hit save. We've got no noticeable change yet because I need to go ahead and tell it that we actually want to capture this and save that somewhere. So inside of the ground, I'm going to open up my virtual textures. And I'm going to add a virtual texture and say, hey, I want to create a lookup for you. I'm going to call this RVT environments and click create volume. So I should be able to tell if that's working by just going back to my root content folder. See this image here? That's the asset that I just created. And we can tell that that's actually a snapshot of my ground from top down. The cool part of that is that if I was to go and open up my grass material, grass blades, this is the big fancy material as it stands. And if I get rid of this base green color and instead sample the runtime virtual texture that we just created, what we end up with is this. So see, the colors are now actually kind of matching the thing beneath it. I've kind of kept a little bit of a shade that was there still going into it. But the next thing that I want to do to stylize the grass, and this is a really good little technique, is by default when you render a model, what we actually do is we say, hey, your surface is facing this way, so we want your tangents to go that way. You know, we want to tell everything to react to lighting as if you're facing that way. A cheeky little trick you can get away with when you're stylizing assets is actually to tell them, hey, face the direction and the lighting information of the landscape instead. And that's super simple. That's literally doing the same thing, except down here, telling it to get the landscapes normal, which you may remember before was just an output, and say, hey, I want you to face that. However, the thing coming into me is a tangent space normal? No, it's a world space normal. When I click apply, we now end up with this kind of look to the grass. And see how that's just got a far more anime style kind of look to what we wanted here. So that's good. We've started to get something together there. But the next thing that I want to work on is I want to start getting this character in order as well. So, actually, before this character, I might work on the sky. So let's look at the sky as our next thing. I'm kind of going to step from landscape to sky, then character to post-process. To work on the sky, there's a few things here that are going on. To begin with, this sun doesn't actually match up with the sun. So some poor artist would have to manually place this sun in the sky to kind of line up with it, which is what we call a bad time. So I'm going to delete that for a second. Now the next thing that's going on here is, honestly, the sky here is really just like the stock standard Unreal Engine sky atmosphere, right? If I pull this down here, we're like, ooh, looks pretty. But it doesn't really look particularly stylized. So what can we do on that front to make it more interesting? I'm going to make a custom sky dome, but I'm going to leverage some of the other systems that we've got and hopefully create something a bit more interesting. Just going to get a sky sphere. I say sky dome still out of habit. And I'm just going to blow this sphere up, or embiggen, to 800, right? So this is really big. This thing's wrapping around the world. I'm now going to set up a material that represents this horizon. So I'm going to call this m_horizon. And this is going to be, anything in here will be now on my sky once I set it up. So I'm going to say to this thing, hey, don't take in lighting values. Okay? And just to test it out, I'm just going to plug in a red value. We pop back to here. We drop it on the horizon. And we can see that that's working. It's not pretty, but it's working. So what I'm going to take advantage of is this. There's a thing that we can access within the Unreal Engine's integrated sky system. We have a fantastic little node called Sky Atmosphere View Luminance, which was definitely named by an engineer. What this essentially does is this takes the color data that you would normally see on the horizon, but runs it through a material first. Do you get what I mean? So it's just kind of looking up, hey, if I'm looking in that direction, what would the horizon be? Cool. Now, I've done that because what I would love to do is kind of step that. So check this out. We're going to do a little bit of math, because math is fun. If we were to think of a linear gradient going from 0 to 1, okay, if you were to kind of stylize a lot of things, what you often do is, instead of having like a smooth transition from one thing to the other, you often kind of like have it stepping towards the color and getting a bit closer and closer to what you want. Now, the math for that's actually really straightforward, right? If I was to multiply that value by 10, that's now 0 to 10, right? If I was to then run a rounding function, which says get rid of all of the decimal places, that's now from 0 to 10, but you can see that there's those bars there, because it's now just the integers rather than the floats. And if I was to divide it back by that initial number, it's no longer 0 to 10, it's now 0 to 1 again. Except this time around, we've got that stepping pattern. You all with me? Sick. So, if I wanted to, I can get rid of this gradient and I can say, hey, what if we did that to the sky instead? Now, generally speaking, when you're handling color, you're usually dealing with it as RGB, red, green, blue, right? But we can deal with it another way. Some of you may have dealt with HSV before, which is hue, saturation, and value. If I was to go ahead and get RGB to HSV, I can say, hey, don't step the color, just step the amount of saturation between them. Anyway, what that looks like is this. Whoop. Sorry. I'm going to say to it, hey, I want to turn it into HSV, and I just want to step the saturation. Okay? Afterwards, I want to combine them back to where they were, as they were. And because my mother raised me right, I'm going to make a variable. And just have that set up. Now this has to go back into being RGB again. But what we've done is we've gotten the horizon colors that were there. And you can see now that we've got this kind of stepped effect. You see that? So we've kind of gotten something. And it's kind of nice, right? Because like that is just using the standard, reasonably scientifically accurate horizon system in Unreal, but it's kind of saying, hey, before you do that, can we just maybe have some fun with that? I will flag that this is definitely better when eye adaptation is turned off. If you have eye adaptation turned on, you won't get that same effect. But I really wanted everyone to just be aware of that kind of stepping that we can do. So let's go ahead and fix the sun, which is a phrase that you can really only say inside of game development. certainly not in astronomy. And what we're going to do next is we're going to get the sun and project it to where the sun is. You get me? So I'm going to get this and I'm going to say, hey, there's a fancy little function here called sky atmosphere image. And all this does is this takes a texture object, which fortunately I have one. It takes a texture object and then it says what direction. And I say the direction of the skylight. Okay? When we hit apply, you can now see that that texture is being projected to that location, right? There is a problem, which is if I turn around, it's also projected at the inverse, right? Don't worry, if you ever get that, that's super quick to solve. You literally just get the mask value and multiply that by the result, and that will turn that off. Now, it is red, green, and blue right now because I didn't fully prep this asset to look like that. So I'm just going to convert this to something that's monochrome. And then I'm going to multiply it against some sort of sun color. Sun color. Oops, sorry, I want a vector param. What a fool. Okay, great. So we've got that. We kind of want to just throw some sort of vague yellow onto it. And, you know, if you wanted to scale it, you can do that as well. So shrink it down. And if you want to have it rotating, you can just run a time value into that. But in the meantime, we've kind of got ourselves a nice, cute little friendly Skylaz Sky Dome. Didn't really take much work to really get done. The next thing I'm going to work on, though, is I'm going to start working on this character. All right. So this is the type of stuff here that will probably make your rendering engineers groan. But, you know, I can dodge pretty quickly. So I'm going to make a new material called m_overlay. And we're going to leverage a feature in Unreal that allows us to kind of change her lighting a bit. Okay? So by default, how this works is we render all of the stuff that's in the scene. The gbuffer does its stuff. But what I really want to do is after it's rendered that, I actually want to kind of go back and say, hey, can I look at the information you've got and recombine them in a different way to get a bit of a more stylized look? And there's a great feature inside of Unreal that a lot of people don't know about that works really well for not only stylizing assets, but also things like adding shields and things like that over the top of people. So it's called an overlay material. And the overlay material, when you apply it to a skeletal mesh, just does an extra pass of the entire mesh. Even if they have 12 material channels normally, it just does the whole mesh in a single pass, right? And the reason that's super handy is that we can access all sorts of information through that. If this was translucent, it means that we can access the information after we've rendered the initial scene. So I'm going to set this to translucent and unlit. And check this out. I can actually access information such as the base color. So this will actually bypass. Notice we've lost all of the lighting on the character. We've kind of just gone back to a completely flat character. That's because we're able to kind of step into this and say, hey, what did you look like beforehand? But this allows me to kind of remix that initial material in some way. And this is a really good way to stylize characters, in my opinion. Because we can do things like, we can get that and we can say, hey, if this is the version of her that's lit, what does the version of her that's unlit look like? So what does she look like when she's in darkness? I'm going to make this a desaturated version of her, right? So we'll get something that is grayscale. And there's a really handy node that we can use called Bounding Box UVW. What this node does, apologies for shooting through the graphs so quickly, I'm just got a lot to show you all. What this node does is Bounding Box UVW actually finds out how big the object is and says the back of the object is 0, the front of the object is 1. How is it on the y-axis? 0 to 1. And on the z-axis, or Z for the Americans within here, 0 to 1, right? So in this case, I'm just getting that z-axis, can't stop, won't stop, and I'm going to go ahead and use that as a way of kind of adding that kind of little bit of darkness down the bottom of her, and I'm going to set a color there. We'll change that in a sec, and I'll use that to kind of control what she looks like. So the fun part of that is, you know, I can just go to here, and I can use what is called a curve. I'm going to make it a linear color, and I'm going to call this character lighting curve. All right? And within this, we can set this up to be what we want her to look like whenever it's touching the ground and what it looks like up top, right? So I'm going to get you and maybe set you to like a dark green. We don't want this to be white. I'm going to kind of go for like a darker gray, I feel. Let's curve that. And I might push this up a little bit further. That probably looks okay. Okay, so when she's in shadow, this is what we want her to look like. Now, Unreal has a little optimization in it called atlasing. And what it does is it lets you bundle a bunch of curves together into a texture. So I'm just going to call this like stylization atlas. And I'm going to add this curve to it. You can see that other curves that have been made for skies and stuff are in there, but I just need this one. Anyway, back in my overlay material, instead of being just darkness here, I say, hey, I actually want you to look up the color from a curve. And it'll be like, well, which atlas? And I say that atlas. Which curve? And I say that curve. And when I pull that back, you can now see that we've got that dark green here. Also, just a pro tip if you're doing this kind of stuff. If I was to open up the curve again, you can actually edit this in the window, which is really handy. Like if I looked at that and I wanted to pull that down or pull it all the way up, it's a really good way to kind of change these things in place and really dial in stuff. So don't use it for just this. Like using this for the horizon skies and stuff like that could have been a really good way to just stylize the sky as well. Curves are really powerful and no one seems to know about them. Okay, so we'll pretend this is what she looks like when she's in darkness. We jump back to where we were. And as I said, we want to have a version of her that is in the light, which is just going to be that. But how do we find out her lighting data? So this is the part that the rendering engineers get angry at me for, but let's do it. And that is that if you find out what, if I know the base color, okay, and I know the final color of the scene, I'm actually able to divide the final color by the base color, and it will give me this. Oops, sorry, I should have desaturated that first, because I really just want the grayscale value. Cool. So that value there, see how it looks like she's lit like any other object? But she's not, right? Like we bypassed all that. So what we're actually getting there, if you think about it, is actually the lighting data from a 0 to 1, or close-ish to it. And that means we can have fun. Like if I looked at that and I was like, hey, I want your shadows to be a little more interesting, what if we went back to our horizon and remember that step function that I wrote just before? This one, where we just divided it? I could drop that straight in here and I could say, hey, I want your shadows to be stepped. Let's do fewer steps because 10 is a big number. And we can see how that's a much harsher line that we're kind of getting there. We've kind of got that kind of slightly more stylized look to it. But the fun part here is, we can get that and then say, hey, that's what the shaded version of you looks like. I want you, sorry folks, it's a new keyboard that's sitting on top of a cardboard box. Whenever you are in darkness, look like that. And whenever you are lit, look like this. Now, if you get this error, it's telling you that by default, this node gives you a 4-vec, so RGBA, and we just want to get RGB. It's a little gotcha, but it's literally a checkbox to fix, as is the case with a lot of Unreal. And from there, we've kind of set up like a little bit of a stylized lighting for her, right? So this was just like a real quick thing for us to do, but let's do more than her. Let's do the world, okay? So if we wanted to get this world and overlay it in such a way that it looks like, let's do an outline shader next. What we can do is I can create a material called m_outlines, and I'm going to set this to not be a surface, but rather a post-process, okay? And in my world, when I look at the post-process, I can say, hey, I want you to run through a material before you render the scene. So it actually gets the incoming image, runs it through this material first, at which point I can do all sorts of devious things to it, and then we can move on, right? So if I get this m_outlines, we can access things like the scene texture, right? So in the same way that we had the base color and whatnot just before, I could plug that in, and we can see that we're getting some of that. It looks a little odd here. I'll get into that in a bit. But we can still access all of that data. Now, I bring this up because here's a fun little thing you can do. When you spell it correctly, sorry. You can access the scene depth at any given point. So what that means, I'm going to divide it by 5,000 and then explain it. What that means is this. So because we can find out how far away a pixel is, I can look at it and I can say, hey, what it says is if a pixel is touching my eyeball, gross, that would be a value of 0. But if the thing is all the way over there, like 50 meters away, by dividing it by 5,000, that says that's now a value of 1, right? Because 5,000 divided by 5,000 equals 1. So what we can actually do to that is we can use that calculation in different ways. For instance, if I look at a pixel, and I look at the pixel above, below, left and right, what I'm able to actually do is say, hey, if the distance between you is really big, that actually tells me that that pixel's on the edge of something, right? Because if this pixel's here, and the next pixel is like way off in the distance, then we know that something is afoot at the circle K. So what we want to do here is we get that value, which is our scene depth, and we compare it. Now this is a little fiddly, and I know anyone in the audience that knows HLSL is like, dude, you could have typed that in code, and you're right, but we're doing it this way. So I can now say, hey, offset it on the y-axis, the x-axis, the negative y, and negative x. We're going to get the scene depth, and I'm going to find just the screen position. So that's the default middle cell, right? I'm now going to find out what is 1 pixel on the y-axis. I'm going to find out what is 1 pixel on the x-axis. I'm going to find out negative y and negative x. And I know that's a little involved, but that's okay. You can look at screenshots of this later. Okay, so if we want to get the average pixel depth, you just add them all together and divide them by the number of things, right? That's how you find out the average of any set of numbers. We all did primary school math. Whoop. Okay, and with that said, this is now going to be the average distance of the pixels around it, which means this minus this will give me this. All right, so we're starting to get somewhere. Not quite there yet. First thing is that is very shimmery, right? It's not a good time. So to get rid of that shimmering, what we actually have to do is tell this, hey, when you're doing the post-process, can you do it before you run anti-aliasing? Because it would really be nice, you know? So let's kind of smooth that thing out. And you can do that in a post-process by just saying, hey, I want you to do it at this point during the pass, which is looking a little bit nicer. But you can now see Bloom actually kicks in over the top of it as well, which is a funny quirk. So we can see that that's what's going on there. If you want a value to not go above 1 or below 0, you can use a saturate. It's basically a clamp. And I can flip it. And when I flip it, we've got this. If we wanted to include her, by the way, in the overlay material, you can literally tell her to process at a different point, and she would now be included in the post-process as well. So it's up to you whether you want her to pass before or after it, right? But the sky is obviously still a problem. Fortunately, I can fix the sky, which sounds more impressive than it is. I literally just say is sky, and that will remove the sky from depth tests. So we're starting to get somewhere here that's kind of interesting. We're getting some nicer visuals together. The next thing that I'm going to do is quickly throw in a thatching effect. So if I wanted the world to look like it's been sketched, that sounds like a nice thing for us to really add to these outlines, right? So let's go ahead and do that. I'm going to get you do it using a really common node. Most people that have used Unreal Materials for a while are familiar with world-aligned textures. It just projects a texture along this axis and this axis, X, Y, and Z, and blends them together. I need a texture object, which I'll put in. I feel like it's called Scratch. No. Just played too much Alan Wake. Textured paper. Okay, and we can see that that's projecting a texture into the world there, but it's stretching along here. And it's stretching along there because there's a little bit of a gotcha, but you basically need to tell the thing, hey, look at the direction that the world normal is facing. That's a definite gotcha. But when I plug that in, it may be kind of hard on that screen, but you can see that that's all wrapped in scratches, yeah? All right, so if that's wrapped in scratches, what we're going to do here is we're going to do the exact same thing we did on the overlay, where we find out what the scene texture is. We say to it, hey, what is the current color, which is called the post-process input. And we're doing the exact same logic we did moments ago in the other one, right? Like I desat that, I divide it by the color. And if I do that on here, that tells me, I'll fix that in a sec, that tells me where the shading is. So what I'm going to do is saturate it, flip it, and if I do this, what we're now left with is a white mask wherever the shadows are. Do you see that? And if I was to multiply that against the scratches, I'm just going to grab the G channel. What we're left with is only the scratches in those locations. And when I flip it back, we've now got that. Okay, so we've now got that kind of like shaded in effect. Looks a little bit weird on such a bright screen, but we can multiply that together to say, hey, what does the shading look like? Now the last little thing I'm going to do, there's just a couple of minutes left in this presentation. Last little thing I'm going to do is, what I've done ahead of time is I've made a very easy little simulation stage. And what it does is this. See this texture? This texture is a render target. And wherever she is in the world, it paints her position to that texture. Do you see that? So if I wanted her to blend the world back into herself, by the way, making that effect is 4 minutes, but I couldn't fit it into my 30-minute slot for this talk. I tried. If I wanted to blend between the two, I can actually do that really easily in the post-process. Because what I can say to it is I can say, hey, find out where that is in the world, the pixel that we're looking at, and if I divide it by the size of the map, which is the size of this texture shrunk down, and I add 0.5, this will actually give me that will actually show me where she is. See how that texture is now being projected back onto the world? Now, a cool thing that you can do in Unreal that a lot of folks aren't aware of, which I'm just going to clamp this so it doesn't repeat into infinity. A cool thing you can do in Unreal that a lot of folks are unaware of is we have a height lerp, which says using a height map, like blend those things together. And I'm just going to say, hey, this represents what is and isn't colored. The height texture is going to be some random brush strokes that'll look good. So I'll just drag in some brush strokes here. And I'll shrink you down a bit. Height texture. And I'm just going to say to this thing, hey, whenever you are darkness, be the outlines. And whenever you are fully lit, the youth, I want you to be this colored version. And what that will do now is that'll paint that kind of effect in instead. I accidentally plugged in alpha. But now, wherever she is in the world, we've got this. And as I run through the world, we're going to kind of blend between those post-processes. Okay? Now, I'm all out of time. I hope this was useful. Thank you all very much. I'm going to stick around for you to chat if you want to talk shop at all. Thank you. We've got another session coming up next.